My name is Josh. I work with that nowadays, and today I'll be talking about towards a smaller, faster web. What does that mean? Gonna talk a little bit about how the web holds out nowadays. Are we? Yeah, this is fine. Talk about what makes for a fast website, and then some things on how to speed it up anno 2016. Yeah, so this is mostly my opinions, or well, my conclusions are my opinions. I'm not a scientist. Don't quote me on any of this. But do your own research. You might find some issues there. I'll tell you stuff I wasn't completely sure about. But so the web anno now. I did a bit of Googling, and turns out like this month in the web, your average website is 2.5 megabytes-ish, of which 1.6 megabytes, am I getting that? Yeah, that looks about right, will be images. Your average JavaScript is like half a meg almost, 23 calls. Your website's doing 107 calls per URL. That's not ideal. That's quite big. But this is the state of the web, and we've been going up for like the last, how long? Well, ever since they start doing this. You can see like all stats on HTTP archive. Turns out websites are pretty big nowadays. Of all those websites that are out there, of all those websites, about 20% are using a CDN, which is not a lot. A third are secure. 3/4 use compression, which is very, very high. So one would presume that people really care about performance. But then only half of the content could be cached. That's, this is the current state. This is probably what your average website looks like, which is something notable is that every single website, on average, uses 37 TCP connections. This means a connection is done, data is transferred. At some point, you hit a cap, and then they're like, oh, cool, let's establish a new TCP connection. This happens 37 times per URL visited. That is quite a bunch of requests, to be fair. Yep. some more interesting stats for this month in the web is the most popular sites, well, sites we all know and love with a proper budget and engineering team, all seem to ship about like half a meg of CSS. Facebook's doing a very, very much better job than the rest. Ships like a third of that. Yeah, these are like all the stats taken from CSS stats, which like benchmarks all the stuff. They just like ping it, inspect CSS. Then there's like two little things you might not know, which is tachyons and base CSS. They're CSS frameworks, and this was taken from their sites and how they're doing. Turns out the whole base CSS site, well, it's like not a complete social network thing. It only rocks up 14 kilobytes, which is pretty sweet. Yeah, the reason why I bring like this up, these numbers like 647, you're like, if they're doing it this big, it should be okay. Actually, if you enumerate, fun fact, if you enumerate the whole CSS language, you end up with 20 kilobytes worth of CSS. This is font size 1 to 99, all the colors, all the properties, everything written to classes, and then gzipped. You can enumerate the CSS language because it's declarative, 20 kilobytes. So everything that is above 20 kilobytes is apparently shipping more than CSS the language is worth. 600, that's like 30 times the CSS spec. That's quite large, one might presume. Friend Adam discovered that. So yeah, something interesting happened in recent times, which is Google came out and they were like, OK, we're going to pump out accelerated mobile pages because we need performance. And it was like, oh, OK, is this a spec? Is this like an open protocol thing? And well, not really. AMP is hosted on Google servers, served by Google. I'm not sure if there's a proper spec. I don't believe so. They have very nice documentation, but they're in control. Yeah, it's got like some shaky UX. There's some weird things going on. It's basically HTML extended with ads served by Google. And one could say this thing is evil because it's not an open standard. But they're trying to make the web fast. which is, it might just be worth it. It might just be exactly what we need. Have a little competition there. Because what Google did is they've been releasing frameworks for forever. They've been releasing documentation on how to make the web fast for forever. The web is still becoming slower and larger. So I think this is their move of being like, yo, we're giving up. We're just use this thing if you want fast websites because all the other methods are not working. And if certain sites are extremely fast, then we need to compete with that. So this talk is a bit about how can we get to like AMP speed without using an evil framework, quote unquote evil. Please don't make Google people upset with me. I appreciate the effort. Pieces of perf. Yeah. So what makes for a fast website? It might be useful to like think about who are we going to be catering for. In this case, Nolan Lawson released like an article last week, which was like the next billion offline first sites, and I forgot the title. I just forgot the title. But he said, he paraphrased someone else, the next billion users of the internet, of the 7 or 8 billion or so people we got, will probably be running Android. They will probably have like 1 gig of RAM and a quad core. They will have a very fresh browser. What they won't have will be a reliable internet connection. They won't have internet all the time. And if they have internet, it might not be very fast. So these are the constraints we're going to be dealing with in the next couple of years. This is a given. So yeah, to break this down, to be like, OK, cool, so these are our constraints. What do we need to cater for? If we're building a fast site, what do we need to think about? We need to think about time spent on network, the time spent booting up our page, the amount of tasks we perform once we're running that page, and then prioritize some tasks. And most importantly is how do people perceive this whole thing? How do they feel about the page? Do they feel it's fast? If they feel it's fast, it's probably fast, right? So that's probably like the most important one, I would say. So per resource, what did I say? Oh yeah. So if you're executing any amount of JavaScript, HTML, or CSS, then these steps will be taken. First, you get a resource, then you interpret said resource, which can take about like 100 milliseconds, but you need to account for when doing a thing. And then you spend time executing the resource. Stuff like rollup says like, hey, we're going to improve like the execution part real hard because everything like it's easier to execute and like go through the initial setup of the script. Whereas the sheer size of the script will determine how much time it's spent on the network and interpreted. Basically, yeah. So the way I like to think about all these things is when you got any type of program, you will have a setup step, which is boot up things to get to a state where we can start reacting to user input, to I/O, which is then the I/O loop, the main loop. And the third part is trickery to make it all seem fast. That is the last step in perf, as I like to see it. Set up network latency, asset size caching. The main loop is probably like parallelism, important and stuff. We'll go over these. Yeah. So some key metrics you probably want to like remember. If you take anything away from this slide and you want to verify one thing in this slide, please verify this slide because getting these numbers right is important. First off, speed of light is pretty important, which is about like 8 times the circle of the Earth in a second. So my math is off here, but I believe that adds like about 50 milliseconds to 100 milliseconds for like any action you do when you cross like the whole globe. Just because of relativity theory, we can't get faster than this. Our what's it called? Our fiber connection uses light. So any connection we make will have like this inherent slowdown. So this is why we have CDNs. This is why we put the content close to the users, so we don't have to be dealing with the slowdown caused by the cap of speed of light. We're also real happy that our planet isn't like larger, because that would like cause serious issues. The first Ethernet packet sent is about 1 kilobyte. The first TCP segment, and TCP segments, I believe, are like upgraded in size. They become like incrementally bigger until they fill up a frame, which is 60 kilobytes. But the first segment is like 4. This can be upgraded, but no one does it. I found this out by Googling a whole bunch. Please do verify this. But these are numbers to know. If you fit within like all of these numbers, except speed of light, you can pretty much speed up your site by a lot. In the earlier site, we said something about like 30 TCP connections made per site. This means that we crossed that 60 kilobyte boundary like 30 times. And setting up like a new one of those is quite expensive, relatively quite expensive. Yeah. So actually, fun fact, Google put out this challenge like not too long ago, where they were like, we're going to rewrite Google+, and we're going to give ourselves a budget of 60 kilobytes or 20 kilobytes HTML, CSS, and JavaScript, or like 60 kilobytes per one of those resources. But they hard capped this, and they made it work. The whole new Google+ site is extremely fast, just because they put hard constraints on their resources. So from 30 down to like 3 or maybe 5 TCP connections is a pretty big leap to make. So that's useful. OK, so how do you use all these things to actually speed it up? First one, setup and caching. You probably want to be using CDN. That's like the biggest win. Put content close to the user. The new wave of like things like IPFS or that, we're like all trying to like make it so that peers are close to each other, and if close peers have the content, we just serve it from there, which saves us a whole lot of round trips and actually reduces the latency problem, because no matter how fast an ISP will be or how fast your fiber connection is, if you need to traverse like all the way to San Francisco to a server to get some data, that will be slow. Yeah, by using, also another thing, if you're building a site, consider using IndexedDB. IndexedDB is pretty fast nowadays. If you're building a Redux app, just plop your whole state inside of IndexedDB, because the only thing that's faster than a fast network is no network calls at all. Service workers are doing like interesting stuff with that. But probably the biggest win you can ever do is like just use a CDN. That will save a lot of stuff. More interesting one, styling. How can we improve like making our style sheets faster? There's a new wave of frameworks in town, which are based on object-oriented CSS. The most notable one is Tachyons, also base CSS, which was on the page, which give you a set amount of classes, sort of like a design framework, and you use those classes throughout your whole application to create a thing. So in order to set, for example, margin top on an element, you append the class MT, or MAT, which is margin top, or MT3, which is margin top 3. I'm messing up words here. But they're single-purpose classes, which means that once you have like your, 20 or 15 kilobytes of CSS worth of like styling, like, oh, we're going to reuse all of this, your CSS can never grow. Because CSS has a bit of a problem that it's the only programming language I know of that works append only. You're going to add a new feature, well, you append it to the existing set of styles. And you like, 5 years in, you've appended a whole bunch of stuff, and now it's like very hard to refactor and like create a new thing. Like all the functional CSS, all these things, they tend to like run into trouble. The only way I've seen it work is using Tachyons. And I've written CSS frameworks before, tools, lots, but the best tools, no, kidding. Yeah, another big win you can do is don't use custom fonts, because they take up like a whole bunch of requests, average like 50 kilobytes, 3 requests. It slows you down by a lot. Yeah, and lastly, execution time. Boring CSS can be interpreted real fast. If you're using variables all over the place and you're like, but Chrome supports that now, you either want to pre-process it or not use it at all. Flexbox is also slower than like floats. Those are things you might want to be considering if you're going to speed it up. Images, I've got no clue. Either don't use images, limit your amount of images, and then like optimize it using gzip and whatnot. But this is not my field. What's the last one? Not last one yet. Yeah. Oh yeah. If you're using gzip, consider using Zopfli which is, so gzip uses a format. It compresses down to a format called deflate. And any browser can read deflate. If it supports gzip unzipping, it supports deflate. Zopfli is a better deflate compatible format. Broadlease nowadays also support, at least by Chrome and probably some others perhaps, which is 30% smaller than gzip. So if you're serving a whole bunch of stuff, anything you serve, you could be like, oh, I'm just going to cut the size of my website by, a third if you're using one of these fancy formats. That could be like a very big gain to make it fast. At least mitigate the network part. No, we're doing it on time. No, we're fine. There's a whole new wave of frameworks nowadays, which are about like 5 kilobytes. I may or may not have written one, which includes stuff like, OK, little rant here. How much do you need from, OK, let's thought experiment. Let's build a front-end client-side router. What do we need? We probably need a routing system, which if we use a tree, that's pretty easy. You can implement a tree structure in JavaScript in 50 lines. Then what else do we need? We need history support. You can implement history support also in like about 100 lines. You want to have like a very fancy, cool recursive API. Well, that will take you like a couple hundred more lines, and that is your router. A lot of routers, for example, for things like Angular back in the day, they're like tens or like in the tens of kilobytes range for something that could be written down on like a sheet of paper. A lot of frameworks are doing extremely complicated things with their routers, and it's not needed. And a lot of these frameworks, they have like a lot of cruft to it, but I honestly believe that if we were all to build like components from first principle, we could cross down like the whole JavaScript thing down to like every single page can be less than like 10 kilobytes or like 60 kilobytes for sure. There's a new wave of frameworks in town. It might be worth considering using those at some point. Also, don't use Node Core modules in your bundle if you're using Browserify, or I don't know how Webpack does it. Bundling in the cert or something can like cost you tanks for kilobytes. Might not be worth it. If you're doing isomorphic JavaScript, consider running disk, which is a tool to analyze your bundles. So you can see what you're running, actually. And don't run Node Core bundles. How many slides do I got? Should probably hurry up. Oh yeah, if you're doing network things, consider running as fast, executing something as fast as possible and putting it inside your browser. Oh yeah, HTTP2 is an interesting one. Because people often praise HTTP2 as like the one solution that will like fix all of our networking problems. But something to keep in mind is that HTTP2 will not make your network, will not increase your throughput. Because you still got the constraints. If you're in a tunnel and you don't have any network, HTTP2 is not going to help you. If you have like a 5 megabyte download speed in a hotel room, for example, HTTP2 is probably not going to help you. The only thing it hard adds, to my knowledge, is binary encoding of headers in HTTP requests. So those will be smaller, and it adds like this whole concurrency thing. But your throughput is not improved. So you may not always need HTTP2, and all the other constraints are you should remember those because this will not make it magically go away. Yeah, just try not to hit the network basically. Oh yeah, some JavaScript things. We've gone over this. Oh yeah, something cool you can do if you're going to optimize your applications at some point. Something you might want to do is static evaluate resources, which means that if you have an expression like 3 and 2, ahead of time compile this and evaluate it and turn it into something else. If you, for example, have a router or anything that has a setup step, consider executing that ahead of time, getting the output of said thing. So whenever you execute a resource, the initial stack of like booting up will disappear, basically. In the case of the router I've built, we've got a thing where we traverse a bunch of arrays, create a bunch of objects, then go over the objects, create a new object, and then that is our router. If we would do that ahead of time and just code generate that, inline that into our bundle, then every time a client starts, when they hit refresh, you have no CPU spike because it's a static expression, and it will be just extremely fast. It will be like booted. Which is the fancy version of doing this. This is the base idea, but you can use it using packages like static-eval to optimize certain performance-heavy parts when you're booting up, which is basically macros. Oh yeah, Facebook's doing some cool things with this, where they interpret your whole bundle and they do it ahead of time. I'm not sure what status is on that, but they had a thing. When you're running applications in JavaScript, the one thing you should probably keep in mind is GC pauses. Whenever you create a new object and you dereference it, you like, dereference is the wrong word, but you no longer reference it, it will need to be garbage collected, so you don't go out of memory. This is extremely slow. Basically, all the immutable frameworks pretty much use like a lot of new objects being created, but you probably don't want to be doing that. You want to be using mutability. So instead of creating a new object, you just change a value on an object and pretend it was a new object, which is how immutable.js does it, I believe. Yeah. Try not to do immutable things. I believe also NPM 3, the first release, had some issues with this, which made it not so fast. Yeah, if you're writing code, use ES3 because it has, like, if you look at the assembly output of whatever scripts you're running, ES3 is extremely predictable and is optimizable. Newer things like ES6 may not have certain optimizations. They might start doing like a whole bunch of like loops in the machine code. Where they shouldn't be doing loops, where it should just be like a straight thing. Use ES3 if you care about performance, please. Yeah, parallelism. Oh yeah, we got cores now. We should be using threads. We can be using threads. That's my slide. I haven't been using threads yet. The base idea is native applications. They have a main UI thread, and everything else is off that thread, and this thread is on a single core. So the whole core just gets to do UI, so everything feels real smooth. You can do that in JavaScript nowadays. Nolan Lawson has done like a whole bunch of work on this. I'm slightly just getting started with it, but the base idea is that. Might be something worth considering for the future if you're building fast apps. Yeah, oh, I just talked about all this. Oh yeah, last one, final one, I think, final one. Request animation frame. If you're building an application, consider using that because it hard limits the amount of actions, the amount of repaints done on your DOM, and it can like make a 1,000 times perf improvement if compared to like every single action you do actually starts painting. Request animation frame is, if you care about performance, is amazing. Also, you can use these loops, these debounce loops of don't flush anything yet, by using stuff like debounce on input events. You can be like, oh, click, don't actually send them into the body of my application. Just keep them here and then flush like the eventual state of the thing. I'm not sure if I explained that well. If you want to hear more about this, hit me up later. I'm still like, oh god, time budget. Yeah, so summary. Sites are pretty big today. We can make a whole bunch of optimizations across like the network, across initialization time, across like execution time. Our sites don't have to be 1.5 megabytes. People are actually shipping sites right now in under 60 kilobytes, like Google. And that is great. And oh god, GC pauses. You can't get around those. Yeah, thank you very much.